Hello friends, welcome to Java EE JPA EJB tutorial. So now we are starting a new sub-series, Stateful Session Bean. So in the previous 4-part video, we learned about the Stateless Session Bean. So here in this video, we will learn what is a Stateful Session Bean. So in this video, we will learn the basics of Stateful Session Bean, and at the same time, we will compare this Stateful Session Bean with Stateless Session Bean. So these are all the prerequisites. Set up Wildfly with Eclipse. That is explained in this video, playlist 06. So this playlist 06 is for servlet. There we explained how to set up Wildfly 10.x with Eclipse Neon. So this sub-series depends upon project setup, which is part of this EJP tutorial. Watch the video tutorial 03. Here we created projects. So we created 4 standard projects, and all our video tutorial in this series depends on these 4 projects. So make sure you create those 4 projects. So if you are already created these 4 projects as part of the previous tutorial, then you can directly jump to this tutorial. So the tutorial requires exposure to Wildfly, I mean the servlet and JSP. So this EJP course won't go deep in servlet as well as JSP. We will try to use it in a minimal way, but definitely exposure is required. But if you want to know the knowledge of servlet and JSP, then you can go through these 2 playlists. Alright, now let's go to Stateful Session Bean. So first let us look at the stateless as a preview, as a recap. Stateless Session Bean does not store bean state between requests. We saw that in the previous video. We had a function that returns some string, and whoever is the client, the functionality will be same. But you can even create a stateless session bean that receives parameter. That's the most frequently used approach, that will receive some parameter. Based on that parameter, the stateful session bean will perform some operation, then it will return the result to the caller. But in the next request, there is no dependency on the previous request, whatever data passed to it. So the data received, data will get processed, and the result will be returned back to the caller. So one round trip, one request and one response. With that, the work of the stateless session bean is over. So since that's the case, all bean instances are same, and any bean can respond to the user request. Why? Because it's bound to a single request and response. So when a bean instance is ready, it can service any client request. So the bean is not dependent on a particular client. So it's bound to a request and response. It depends on only one round trip, or it depends only on the parameter. And in the next call, it doesn't bother what is passed as a parameter in the previous request. So that's why all bean instances are same. Any bean can respond to a user request. So we already know this. So for this same reason, any bean can respond to a user request. For the same reason, the container in the sense wildfly. If we are using glassfish is the container. The vendor provides the container implementation. So that container keeps pool of stateless session bean. Pool of means it will have multiple instance which is ready in the sense no need to create the instance. So the instance are once created, they will be kept in a pool and waiting for any incoming request. So when there is a incoming request, a free bean will service that request. Now let's go to stateful session. So stateful session bean stores bean state between requests. So if there are 3 or 2 requests or more than one request 2 knows what got received in request 1, or we can say request 1 will make some state change on the bean, and that state change is remembered in request 2 when it originates from the same client. So since it maintains the state, bean objects are different for different client. So that means if a bean is created for client 1, it may not be same for request coming from a client 2. But you have to note that the bean object will be same for the multiple request that originates from the same client till the browser session closes. So bean object pooling is not possible here. Why? Because the bean stateful session bean maintains the state, and the state belongs to a particular client. So the state of client 1 is different from state of client 2. So since that's the case, here object pooling will not be possible. That means we cannot create object in advance and keep it in a pool and service any client request, because the state may differ. So let's assume browser timeout is 10 minutes. In a crowded environment, when client session is not active but still alive in the sense the bean is still alive, as a session timeout is 10 minutes. So here we are assuming that browser timeout is 10 minutes, right? So in this case, the container will store the bean state to a disk. So it won't hold for a long time a bean in memory, especially the stateful session bean. Stateless session bean, definitely it will keep in memory. That's the purpose of the stateless session bean. It will sit in the memory waiting for the client request, since any bean can arbitrarily receive the client and process the request and send the response back. Here, since the state is maintained, and if bean is staying for a long time in the memory, and when there is no activity, then the container in the sense the container implementation, whether it is Wildfly or whoever is the vendor who is implementing the EJP, so the container will store the bean state to disk. So from memory it will go to the disk. So which disk? So the disk of the server in which the application server is running. So it goes to the disk. Later, when user activates the session in the sense within this 10 minutes timeout period, if they activates the session, then the container will read the bean state from disk. So why it is doing this? Why? Because we already told in a crowded environment. So in crowded environment there will be multiple requests, and since we cannot create the instance and store it in the pool, and a bean will store the state information of the client request, we cannot keep it for a long time in the memory. Why? Because the memory will run out if there are multiple client who's making requests to the server. And when client session is not active, it's not good to keep the bean in the memory. just for nothing. So it will be stored into the disk. So later when the client makes a request within this 10 minutes timeout period, so here we are assuming it, a browser timeout is 10 minutes. Before this 10 minutes timeout period, then the bean will read from the disk and it will be kept in the memory. So let's see this with an example. So let's assume that this is the client who is browsing and sending some request to the server, and in server side there is a stateful session bean that is processing the request. And so he is making the request. It can be one or multiple requests. Assume that there is a shopping cart. He is browsing, searching and adding the product. So the list of product is maintained in a stateful session bean. Let's assume like that. So he may be sent multiple requests, and let us assume he added some 3 or 4 products. After that he left the browser, he or she, and the browser is idle. So during this 2-minute period, if you see, in server there will be a stateful session bean, but the browser session is inactive for 5 minutes and browser timeout is 10 minutes. So if timeout occurs, the data will be lost, but it's idle for 5 minutes. That means total 7. The browser session is started here and 7 minutes is spent, and it is inactive for 5 minutes. That means ideal is a timeout is 10 minutes on browser session, only 5 minutes it was ideal. Now here the user once again came back to the same browser session and he started browsing some other product using search, or he is adding product to cart or removing it. Let's assume like that. So on the browser, let's assume that no need to assume. So in the server side, if you see, the container that manages all the stateful session bean. Let's assume that there are a lot of stateful session bean. We will also assume these beans are from same classes, say the account manager or shopping cart. So that's the bean. So let's assume, since here we talked about shopping cart, let's assume these beans are shopping cart beans. And if you see, so if you see here, there are different clients from a different part of the world. So World Wide Web, right? So different part of the web browsing the same site, and they are doing some purchase action. So they will have their own shopping cart. So the shopping cart will be different for the clients 1, 2, 3, 4, 5, and here is our example 6. So, and you may know when there are multiple clients, how the memory will get occupied. So there will be multiple objects. So here we already talked about the pool, right? Pool will not be possible. Why? Because different bean will have a different state. So this user may have different preference and different shopping cart detail, and this one have a different shopping cart information. So since the object holding these objects in memory is costly, and what happens when such a ideal session is encountered by the server, the container will write the information to the disk. That means this object will go to disk, and so it happens during this period. So if it sees there is no interaction for some period of time, then the container will decide to keep the object to the disk. That means it will clear this memory so that if any new incoming request comes, it can allocate the space. right? So after 5 minutes, when user makes a request, the corresponding object here that's in the disk, so it will take back this object and places that in the memory. So this kind of action is done by the container. So writing it to the disk is called passivation. So it passivates the bean. Here it is activating the bean. So when it will passivate and when it will activate it depends on the container. So the container will look for the memory requirement and how much traffic is there. Based on that it will decide. So that's the main difference on the container side. If you see, if your bean is stateful, then it writes the bean to disk and it will take back. So this is called passivate and this one is activate. So storing bean state to disk is passivation. So we already saw this. So this is the passivation, and reading it back and making the object back to memory is activation. So writing it to disk is passivation and reading it back is activation, and it happens for stateful session bean. And this passivation and activation is it's not for the stateless session bean. In stateless session bean, it will keep the object in memory, and those objects will live for a longer time period. So when we are coding the stateful and stateless session bean, we need to understand what is the client role and the server role. This will make us write the code in a efficient way. So when coding for stateless bean, we should remember the bean may already exist in the pool. No need to keep it in a session. So stateless session bean means you can go for lookup, create the instance, pass the parameters. Once the value is returned, use it. That's all. So you no need to remember the bean instance between the session. That means here we are asking no need to keep the bean instance. That means the client's part of the bean instance in a session or application variable. Don't keep it in cookie or session variable, because it's a the bean object will be remembered for one request and one response cycle. So no need to keep it in a session context, I mean. So when coding for stateful, the client can keep the proxy object in a session context. So if you are coding for a shopping cart, then create the instance of, the proxy instance, then keep it in the session context so that the proxy will be remembered for a next request session. So when a proxy is the same in the next request, the server also knows that the object needs to be kept in memory because the proxy is alive on the client side, right? So that's why we have to keep the proxy object in the session context or some other means. So if you session context is most commonly used, and if you know how to remember it using some static object, so it's up to the client side programmer's preference. Session context is the most frequent used one because stateful session bean for a particular user session. So session context is the best one to keep the proxy. So look beside to understand how client uses proxy object to mimic the real server object. So this will be the server. In server, the stateful session beans will be created. So client 1, if you see, it will use the proxy. So the proxy and stub or proxy skeleton, the old COM programmer, DCOM programmer says that way. So let's say this is the object. The memories are different, right? This one will be the memory on the server, and here the memory is on the client box, the user's browsing box. So what happens? The browser will have a proxy object, and if you see, we call this as a proxy. Proxy means it's not real but a duplicate object which will mimic the same stuff whatever is there on the server. So it will have same behavior or same method call. So a proxy will be maintained here. So here if you call X in client side programming, whether you are using a JSP or servlet, whatever it is, a web client or even a Java application client. In the very first video, we talked about what are all the possible EJB client. So here we are talking about those EJB client. A proxy will get maintained, and inside the client coding, if you make a call to the proxy object.x, that means you are making call to servers X, but actually here we are making call to X here, and let's say if he is passed some parameter, this will get translated and it goes as a stream to the server machine, and in server once again the call will be made here. So here if you are making call to x1,2 by passing 2 parameter, then those 2 parameters will get streamed here. It goes to the server, and those streamed will read back, and here call is made again. So this is what called proxy. So here if there is one more client, this is a different proxy, and that proxy is mapped to a real object on the server. So the server knows that when the proxy is alive, the server knows that the tied object, real object in the memory pool should also live. So that's why here we are saying when we are coding for stateful session bean, we can keep the proxy alive so that the real object on the server also will be alive. So here this is client 1 proxy, and this one is a client 2 proxy. Thereby 2 object lives on the server. You can see how the object will grow here on the server when there are multiple clients. So that's why when there is a long timeout, the object will be returned to the disk. Activation and passivation we talked in the previous slide, right? That will come into picture. So in server side, so this activation and passivation is for stateful session bean. For stateless session bean, activation and passivation won't come into picture, but we will have the object pool. So even the object lives in object pool, still this proxy object holds. So let's say this is the object pool for stateful, and these two are for this two is stateful, and this object that is living in the object pool is stateless. So the client 2 is using some object stateless session bean object. So here also there is a proxy and skeleton, and proxy and real object, so that's valid. So in server side, if you see, when request is for stateless bean, server look at the object pool. When all objects are busy, it will create new instance or ask ideal bean in the pool to serve the request. So let's say there are 3 objects in the pool and one request is going, and since all 3 objects are free, it will arbitrarily pick one object, then it will ask to serve the request. So the moment you go for lookup, the proxy will get created. You will make a request, it will respond back. That's all. So this will be released. And holding proxy is not useful here. I mean, holding proxy in the sense in the session context or some other means. So when request is for a stateful bean, server will keep the object in the memory. So server will keep the object in memory, and when proxy arrives, and if it is ideal, it may even passivate the object. When it wakes up, it will activate it. So the server will keep the object in memory. If object is not active for a long time, it will passivate the object. And if a session timeout occurs, it even removes the object from the memory. Or if user closes the browser session, that time also the container will remove the object. So that's the lifetime. When user opens the browser session, he will pass multiple requests, then he will close the browser session. Here bean alive, process the request, and it gets here. Stateful session bean. Stateless session bean, that's completely different. It will live for a long time, and since it lives in the pool, and it can arbitrarily serve any client request. So pool of object, if it is a stateless bean, and here lifetime is completely different. It will live for a long period, and the lifetime for the stateful session bean is different, and each object is different here based on the client. So we can say this is for client 1, this is for client 2, this is for client 3, this is for client 4. But here in a stateless session bean, all are same. There is no difference between these bean objects, since it doesn't maintain any state. That means this bean can serve any client request, but this is specific for a specific client request. That's where object timeout, activate, and passivate, everything is coming into picture. Stateful bean's lifetime is decided by the browser session. Browser session means user creates the browser, he do some processing, and he closes the browser. The bean will be dead. Or he is idle for a long period of time, 4 or 5 days or 6 or 7 hours, object will be dead. So here there is a demo, and going forward we will create an example to mimic the shopping cart, and we will see how stateful session bean works for this example. That's all here in this video. Thank you for watching. Bye.